Hello everyone, today is day 18 of solving a LeetCode problem every day. So today I solved daily temperatures. So you're given an array of integers temperatures where temperature I represents the daily temperature on the ith day. Return an array result where result I is the number of days after the ith day before a warmer temperature appears on a future day. If there is no day in the future where a warmer temperature will appear for the ith day, set result I to 0 instead. So let me zoom into this a little bit. So we have a test case here where we have 30, 38, 30, 36, 35, 40, and 28. So 30, the first position in the output array is a 1 because one day after 30, we get a day with 38 degrees, which means there's only a 1 day difference in when a warmer temperature appears. Now there's a 4 here because you can count. We have 1, 2, 3, 4. It's 4 days after you encounter a day that's warmer than 38 degrees, and so on and so forth for the rest of this array. So the approach I took to solving this problem is building a stack, and I basically built a stack that's in non-increasing order. So what that means is you can have 30, 29, 29, 27 or 26, 21. Basically, it's in decreasing order where it can also be equal numbers besides each other. And the general idea is, so let's say we have this test case temperatures. So we have temperatures. Let me just copy this. So we have temperatures here. Oops. Cool. So we're gonna build a stack. So we go to the very first value. It's a 30. So we push that to the stack. And then we go to the next value. We compare this with the top of the stack, which is a 30, and it's greater than that. So let me also create this output array. So we see that 38 is greater than 30. So what we're gonna do is add 38 to the stack, but pop 30 and set this to 1 because there's a 1 position difference between, or a 1 day difference between those two temperatures. Then we can keep going. So we add the 30, or we add another 30 to the stack, and then we get to 36, and we see that 36 is larger than 30, and it's a 1 day difference. So at that current position, we set that to be a 1 because 30 is at index 2. So index 2, we make it a 1. And we pop this. Now again, we check if 36 is larger than 38. It's not. So we keep on going. So we add a 35. 35 is less than 36. Then finally, we get to 40. So 40 is greater than 35. So what we're going to do is, so let's see, 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. So 35 is at index 4. So this means this becomes a 1 because there's a 1 day difference between 35 and 40, and we can pop that off the stack. Now we have a 36, and this is less than 40 also, and there's a 2 day difference. So this becomes a 2 here, and we can pop it off the stack. Now we have 38 and 40, and 38 is less than 40. And there is a 4 day difference between them. So we put a 4 there and we can pop it off the stack. Now we're at 28. We push down to the stack because it's less than, and there's no numbers that come after 28, which is warmer, or that comes after 40, which is warmer. So we just put zeros there. So, I mean, that was a kind of simple explanation to what's happening with this algorithm. I hope that helped, but let me just go through the code also real quick. So we start out by initializing the stack. We then build the result array, which is just consists of so if the input size is n, it consists of n zeros. We begin looping through temperatures, and now we have the first condition, which is while stack, because we don't want to go to this condition if stack is empty, because stack -1 would throw an error. But anyways, our second condition is that the temperature at the top of the stack is less than the current temperature that we're at currently. If that's true, what we do is pop, and then in the results array, we set the value to be the difference between I and current. And then finally, regardless of what happens, we append I to the stack. So I'm going to do another example just because I want to do this to kind of show what it looks like with the indexes. But let's say we just have 30, 38. Let's do like 31 and 40. So what would basically happen is this is our stack. This is our result array. So there's 4 input values. So there's going to be, we initialize the results array to be 4 zeros. The stack is empty. So for I in the range of temperatures, stack is currently empty, so we can skip this. We just append I, and I is currently 0 because we're in the first iteration. So we append 0 and then move on to the next iteration where I is equal to 1. Now the stack isn't empty anymore, so we go to the next condition. So we see temperatures as stack -1. So this is the temperatures array. Stack -1 is equal to 0. So while 30 is less than temperatures of I, so I is 1, 30 is less than 38. What we're going to do is we're going to pop the element off the stack, which is a 0, and then we set result of 0 because cur is now set to 0 to be equal to I minus current. So I is 1, current is 0, so this just becomes a 1. And then we add 1 onto the stack. And I'm not going to go through the whole entire thing, but I think you guys get the point. We're essentially building a non-increasing, we're building a stack that is a non-increasing order. And then we pretty much just keep popping back until we encounter an element that's not less than the current element anymore. So the time complexity of the solution is O of n. And the reason why it's O of n is because we're just going to be iterating through all the elements once. And the space complexity, this is also going to be O of n, since we have to now build a stack that can have possibly n elements. So yeah, that's my solution for the day.